Good morning. It's 5 something. Who cares? It's 5. There's a 5 in front. How many of you all have actually seen a 5 on a clock? And it's not dinner time. I see it every day. I love 5 o'clock. You know why? It's quiet. Nobody's bugging you. School's about to start. Oh my God, I'm so excited. All right, you're probably like, what? It's like January? No, it's the end of August. I am recording Unit 5.6 for today. By the way, all of these videos in a very organized fashion can be found at www.N stands for Newman. She is my absolute favorite partner in crime. Krause. Infinity.com. This is where we have all of our videos for you teachers. There's an opportunity to get all of these materials that you can use in your classrooms or just use as an extra resource or whatever. Available to you there as well. So, but I'm going to be called Mr. Key for the next while. You guys know this. Mr. Key, as in answer key. Here we go. Ding, 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 ding. Oh, man, I can't even get that to go right. Let's see, maybe I can use these buttons. Ding, ding. Ah, perfect. Okay, so we're going to solve these. Now, these ones are easy. I even gave you a hint. Actually, that's Mrs. Newman. She must have done that, because look at that. It's got a smiley face. I never like, get it done, kid. She's like, hey, get it done, kid. She's so much more pleasant than I am. She's louder, though. She is. Okay, so we're just going to cross multiply because it's our favorite thing to do. We see 2 fractions and we cross multiply. You can always cross multiply, but on these cases where you have one rational function equal to another rational function, you can simply just multiply. Or cross multiply. So we'll do that. X times, oh, Mr. Krause, didn't you tell us that they're a married couple and you got to put wedding rings around? That's so stupid. What do you mean it's stupid? It's awesome. X times X plus 13, they're a married couple, put rings around them, equals 5 times 6, 30. Oh, okay. This is going to turn into a quadratic. I hope you all see that. We get X squared plus 13X equals 30. Bring the 30 over, you get X squared plus 13X minus 30 equals goose egg. Now we got a little factoring to do. Ka-ching, 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 ka-ching. I'm going to show you a graphical way to do this one, just as a quick check for your answers, only because I like you. Not really. So X and X. Now, this is a negative. It would be so easy to put a 10 and 3 there because they add up to 13, but it's not the right answer because it's negative, because this is negative right here. That means they have to subtract to get 13, not add to get 13, subtract to get 13, and that would be 15 and 2. So our 2 answers are X equals, I don't know why I put parentheses, X equals negative 15, and X equals 2. I promise to show it on the calculator. I'll be right back for that. Every break requires Dunkin' Donuts coffee. Bam! Nailed another commercial. All right, here we go. What we're going to do is, this is a simple way to, just a very simple way to use your graphing calculator to see if you got the right answer. So what we're going to do is this. We're going to come over to our calculator. It's right here. And we're going to enter a new document, new graphs. We're going to just do it graphically. And we're going to call one of them 5 over x. So 5 divided by x. Puts it in there nice. There it is. And then the other one we're going to call, I forgot what we're going to call that one. X plus, I better do this as a fraction. Control division, x plus 13, x plus 13. Oh, I forgot to hit the tab button. And then control division. Man, I knew it all nothing. X, I hate when I do that. X plus 13 all over 6. Huh? I'm sorry, what? So here's what we're going to do. You go into menu. There's a way to get this calculator to find both roots just as very quick. You go to menu. You go to geometry. and points and lines, and intersection points. So you want me to do that again? You go to Menu, Geometry, Points and Lines, and then Points of Intersection, or Intersection Points. Click. Now what it's looking for is you to graph. It says, click on that graph. Yes, I want you to include that graph. Click on this class. I want you to include that graph. Doom. Oh, but I can only see one of them. Oh, I thought it readjusted for us because there's one over here clearly, right? It found it. Oh, it didn't even find it. Man, maybe what we need to do is this. Maybe what we need to do is this. Let's try this. Because that was bugging. That's going to bug me. Let's change this number over here to... I don't have the new I don't have the new software. The new software would have found both of those, and it would tell you this is negative 15. I forgot. I don't have the new software on my computer yet. That's weird. I thought I was going to do that. Okay, I'm going to do that later. But, oops. The new software would find both of those. So that's embarrassing. But, yes, it will be there. The other way to do it... Oh, never mind. I'll show you another example sometime. All right, we're going to cross multiply. Remember what we said? We don't like these negatives, so we got to get rid of it. So just move it and put it right there. All right, so we cross multiply. Ooh, we got wedding rings. Oh, look at the cool couples. They're all married. So x plus 1 times x minus 12 equals negative 7x. Double distribute. I get x squared minus 12x plus x minus 12 equals negative 7x. We're going to bring this 7x over by adding 7x. So on this side, we're just going to end up with 0. Let's see. That's 8x. Negative 12 and 8x is negative 4x. So negative 4x minus 12. Since it's negative, the two numbers have to... since this is negative, they got to subtract to give me 4, and that would be 6 and 2, but they subtract to give me negative 4, so negative 6 and positive 2. So my two answers in this case are x equals negative 2 and x equals 6. You know what? I'm going to try that graphing thing again because I don't think they have to be. I think I do have the new software, or at least I think whatever. Let's try it again one more time. Let's see if it works. So we go into graph mode, and the first one is x plus 1 divided by x. Enter. And the other one is 7 over x minus 12. 7 over, tab, control division, 7 over x minus 12. Shut up. Hitting all the wrong buttons today. Minus 12. Enter. So what I think what were the two answers? 6 and negative 2. We didn't come up with those. Did I put something in there wrong? 7 over x. Oh, x plus 1 over x. 7 over x. Oh, it's negative 7. Man, forgot the negative, and I got all kinds of messed up answers. Negative 7 over 12. Ah, there we go. Now we're getting the right answer. See how they're right there? They're on the graph. That's why I said this one might work. So I think what you have to do is be able to see both of the points of intersection. I think we can see them now. So and then we go into menu, geometry, points and lines, intersection points. Now you got to just click on the two graphs you want to talk about. I want to talk about you, and I want to talk about you. Boom, there it is. There's the first one, x equals 6. Or can I move this? At that point, oh, there it is. I finally got a hold of it. Negative 2. So negative 2 and 6. Those are my two answers. Yay, that worked. Bye. All right, so let's go through the steps for when it's a little more difficult. First thing you're going to do is get rid of negatives. We're going to factor and choose one of each for the common denominator. we're gonna multiply denominators and distribute. You're gonna see, and then we're gonna solve. Factor and check. So we're gonna go through all these crazy steps with all these crazy colors. Oh my God, that's so much fun! I can do that all day. Okay, I won't. So let's go through. Whoa. What do we got here, kids? I don't like the way that's done. All right, so what's the common denominator? I see between 4 and 12, I see 12 and an x, right? So we have an x and 12. So I think our common denominator is 12x. So this one needs to get multiplied by x over x. So this becomes x over 12x plus, this one had to be multiplied by 12. So 12 over 12x is equal to, and if I make this 12x, I got to multiply by 3x, right? So I got to multiply by 3x. So this is 3x over 12x. All right, so let me put these babies together. So I get x plus 12 over 12x equals 3x over 12x. All right, so let me ask you a question. If I had nothing over 5 equals 3 over 5, and I said make them equal, what would you tell me this had to be? A 3? What if I said it was a 3.5? Would you say this has to be a 3.5? So as long as the numerators are equal, the two fractions are equal, right? So at that point, that's all we're going to do here. We just want to make sure that these two numerators are going to be equal to each other. So we set them equal to each other. X plus 12 equals 3x. That's it. That's all you got to do. Bring the x over. I get 2x equals 12, or x equals 6. Simple as that, children. All right, first things first, I don't like this negative here, so we're going to turn this into a positive and put that negative there. The second thing I'm going to do is put some wedding bands around the x minus 1, because that is one full thing. They're married. You got to think of them as a binomial, okay? That's one binomial. All right, so our common denominator, our lowest common denominator here is x, because that's one of the factors, or one of the factors. And then the other one is x minus 1. All right? So this one's missing an x minus 1. So this one's going to be 1, or x minus 1. And then the numerator is missing an x minus 1. Well, 1 times x minus 1 is just x minus 1. Plus, this one's just missing an x. So we'll put an x there. So we get negative 2x over x minus 1. And this one's missing an x minus 1. So we got to put an x minus 1 in the numerator and denominator. Love saying denominator. So the numerator would be 2x minus 2, right? All right, on the left, we're going to put all this stuff together because I have a common denominator. I can just add them. So that's negative x minus 1 over x minus 1 equals 2x minus 2 over x minus 1. So long as now that the denominator is equal, all I got to do is set these two things equal each other, and I should be good to go. Negative x minus 1 equals 2x minus 2. We'll add x, and I get negative 1 equals 3x, add 2, I get 3x equals 1, or divide by 3, I get x equals 1/3. Oh no, Mr. Krause, it must be wrong, it's a fraction. Fractions are your friends, kids. All right. Okay, children. I call you children because that's what you are. Let me try to go through this one a little bit slower. First step is I don't have any negatives to worry about. And, well, this is really 2x over 1. I need the common denominator. Oh, we got some wedding bands. Oh, look at all the married couples. Oh, well, maybe for high school I should say dating. dating. But then I don't want to put wedding bands around dating kids, so that's kind of weird. So let's not do that. So we did that. One of the steps I said was to factor, but I haven't had a problem where I had to factor yet. On the next problem I will. And then find the common denominator. Well, the common denominator must be clearly 2x minus 1. So I'm going to have to multiply this denominator times 2x minus 1. And this denominator times 2x minus 1. Now on the left, they already have the common denominator, so I can put all that stuff together. 3x squared plus 3x minus 4 all over 2x minus 1 is equal to, the denominator here is just 2x minus 1. Now the numerator I got to distribute, right? Negative 2 times 2x is negative 4x. And negative 2 times negative 1 is positive 2. Lots of places to make dumb mistakes there. All right. Well, now that I have that the denominators are equal to each other, really all I got to do is set those numerators equal to each other and see what's going on. So 3x squared plus 3x minus 4 equals negative 4x plus 2. Let's bring these over. We're going to add 4x and subtract 2. So I get 3x squared plus 7x minus 8. All right, since this is harder factoring for you all, I'm going to do it my way, and then I'll do it Noom's way. I always do Noom's way first. I'm going to do my way first because you all think I cheat. So you just look at Newman's way and you just put those answers down. Need some coffee. I know it's got to be 3x and x, excuse me, because that gives me 3x squared. Let's see, the easiest way to multiply to 8 is 4 and 2. I'll just put them in there, 4 and 2. Let's see, that's 6 and 4. Now, because this is negative, they're going to subtract to give me 7. 6 and 4 don't give me 7. That sucked. Why did I say 6 and... Oh, yeah, 4 and 2. Let's try this. 2 and 4. Let's see if that works. That's 12. I knew something was wrong. I'm like, because I'm pretty good at factoring. I'd already gone through all the factoring in my head, and I'm like, none of this works. Why am I doing this? Well, I kept looking down. This should be a minus 6. That was embarrassing, kids. I'm not going to lie. I don't know why I got minus 8 there. Oh, even the baldest of people make mistakes. So let's see. 6 and 3, 6. So the easiest way to multiply to 6 is 2 times 3. I know I can't put the 3 here, so I'm going to put the 3 here and the 2 here, and let's see if that works. This gives me 9 and 2. 9 minus 2 is 7. I want positive 7, so I'll make this plus and I'll make this minus. Okay, so that would give me my two answers are x equals 2/3 and x equals negative 3. So if you choose that method, you're good. Let's try the other way. And we'll do her method over here. I think the first thing is to find the product. So the product would be negative 18 and the sum would be positive 7. So I need two numbers that multiply to negative 18 that add up to positive 7. I believe that would be positive 9 and negative 2. They multiply to negative 18 and they add up to positive 7. So we'll rewrite this baby. 3x squared plus 9x minus 2x minus 6 equals goose egg. On the first two, I can take out a 3x. I'm left with x plus 3. Now, in order for this to work, I have to get an x plus 3 over here. Notice I'm going to copy down this negative 2, and I'm left with x plus 3. Now, be careful. You took out a negative 2. You divided out a negative 2 factor, so even though this is a minus 6, negative 2 times negative 2 times positive 3 is negative 6. Okay, so my first set of parentheses is x plus 3. My second set is 3x minus 2. Either way, you arrive at the exact same solution and get the right answers. All right, kids, let's move on. Oh, you know what? I want to show you real quick that this one can be done graphically as well. So check this out. This is going to be crazy. Crazy. Let's put this over here so I can see it. All right, so we're going to put the whole left side in. Control division, 3x squared over 2x minus 1. I know I could have combined those, but I want to make it look exactly like the original. Control division. So I know that I didn't make any dumb mistake, even when I was combining things or whatever. I easily could have made a mistake. So I'm just going to copy it down, make sure it looks exactly like my original. And it does. And this is going to look kind of funky. That's crazy, Krause. That's crazy. All right. There's that. And then the other side's easy. Ooh, I should have put this up here. The other side's easy. You just hit tab and you type in, why do I keep hitting control? Tab and then -2, because that's the other side. The right side's just -2. That's an easy side. Okay, there they are. So menu, geometry, points and lines, intersection points. Click on this. Click on this. Boom, there they are. -3 and then 0.66667. You kind of need to know that's 2/3. All right, kids, because you can't put 0.66667 on your computer. Your teacher would be like, oh, that's embarrassing. I can't believe you just did that. All right, let's move over. Here we go. Oh, my gosh, it looks so embarrassed. It looks so... All right, I'm going to start the first step with this. The first step we're going to do is get rid of this negative. So we're going to make this a positive and put the negative up there. Then I'm going to put the married couple together. Oh my goodness, did you notice that little sucker right there? Son of a... We need to talk about something. I didn't even notice it until just now. We need to talk about this thing right here. Did you notice that's backwards? We're going to have all kinds of problems if we don't take care of that thing that's backwards right there. So I'm going to take care of that thing first. What I have is -1 over 5 minus x. Now, we talked about this when we were talking about the -1 rule. That thing is backwards. That thing is going to cause us all kinds of problems. So what we want to do is we want to get its equivalent form. So what I'm going to do is I'm going to take this thing and I'm just going to reverse it. X minus 5. Now, I'm going to do that by taking out a -1. Now, notice, if I distribute that -1, I get -x. And then if I multiply -1 times -5, I get +5. Okay, so I can legally do that. Now, the numerator, there's still a -1. All right. Well, okay, 2 negatives make a positive. So what this is really equivalent to is 1 over x minus 5. So you can think about it still as this being the -1 rule. If you come back over here and you say, oh, okay, wait a second, I can just do this. Negative x minus 5 and say, oh yeah, that's really -x minus 1, because remember, that's introducing that -1, and then these two negatives make a positive. So what I have here now is 2x over x plus 5, married x plus 5, plus +1 over x minus 5 equals 10 over, now we have to factor this, x plus 5, x minus 5. All right, let me change colors here a little bit. Let me get the blue, a little bit more festive. All right, so I've got it in factored form. Oh, come on. I've got it in its factored form. And so this would be my common denominator. Remember, we want one of each, and this already has it. So on the left side, on the right side, I don't have anything to do. But on the left side, this one needs an x minus 5. So this numerator needs an x minus 5. This one needs an x plus 5. So this one needs an x plus 5. So I've got 2x times x minus 5. This one needs an x minus 5. X minus 5. Make sure all over x plus 5, x minus 5. plus x plus 5 over x plus 5, x minus 5, equals 10 over x plus 5, x minus 5. Woo! All right, so now that all the denominators are equal to each other, I'm going to add these two denominators up. This is really 2x squared minus 10x. So 2x squared minus 10x plus x plus 5 all over this crazy denominator, x plus 5, x minus 5, equals 10 over x plus 5, x minus 5. Well, now that the denominators are equal to each other, I can set the numerators equal to each other. This is really 2x squared minus 9x, that makes 9x, plus 5, equals 10. Bring the 10 over, subtract 10, so I get 2x squared minus 9x minus 5 equals goose egg. So we got to do this two ways. I'll do it my way first. It's got to be 2x and x. And I'm going to guess this is minus 5 and this is 1, because that's negative 10 plus 1 is negative 9. So my two answers are x equals negative a half and x equals 5. I knew it had to be 5 and 1. I just didn't know which way the 5 went. So let's see. Product. The product is negative 5. The product is negative 10. The sum is negative 9, so I'm assuming that's got to be positive 1 and negative 10. All right, so rewrite it. 2x squared minus 10x plus x plus minus 5 equals 0. Take out a 2x. I'm left with x minus 5. You can't take anything out of this, but you can't stop by taking anything out, so you take out a 1. X minus 5 equals 0. My first factor is x minus 5, which matches this one. And my second factor is 2x plus 1, which matches this one. All right, and then you get the same answers. Fantastic. What do we got? 2 left? 2 more. All right, we'll start this one. This one's not too bad. By the way, by now, you probably should be pausing this and trying it on your own. Clearly, pause. Hey, welcome back. Anyway, clearly the common denominator is x minus 3. So we're going to do 4x over x minus 3 equals, now this one's missing an x minus 3, so this one's missing an x minus 3. So this is 2x minus 3 over x minus 3 plus 12 over x minus 3. Now, in order to avoid that next step, which I can really do, I don't need to really write it over one. Really, all I got to do right now is say, okay, this stuff in the top has to be equal to each other. Because all I'm going to do is put these two together and then set them equal to each other. But that seems like it's a waste of time. I can just do this, 4x equals, I'm going to do that anyway, 2x plus minus 6 plus 12. I'm just going to put all this stuff together anyway. Might as well just do it right there. So I get 4x equals 2x plus 6. Bring the 2x over. I get 2x equals 6 or x equals 3. I told you that one wasn't too bad. Oh my goodness, Miss Newman's going to crush me like a bug. I keep forgetting to do, and I did it with the calculator before, but I keep forgetting to do this. I've been doing it on the calculator and checking my answers, but I forgot. I got to do it. I should be doing it all the time. What answers did we come up with here? Yeah, here's a problem right here. I want to check this one. Actually, we'll come back to this one. Let's check the one we're on, and then we'll come back to that one. So, I can check it using my graphing calculator, which I'm going to do, but then I'm going to talk to you about why we are going to do something weird on this problem. So let's do this on the graphing calculator. All right, so the first one is, it's 4x over x minus 3, so control division, 4x over x minus 3, and then hit enter, and then tab. And then we're going to do 2 plus, and then control division, 12 over x minus 3. And I'm not sure this is actually going to help us out, but we're going to take a look at it anyway. X plus x minus 3. May actually still... All right, so our answer was 3, correct? Those look like they hit each other at some point, maybe? Maybe we need to zoom in there. See, maybe they hit each other right there. I don't even know. But hold on. How about this? Maybe they hit each other down here. What do you notice that we have? Now, something you should know. What do you notice that we have? What is this line right here? If I graphed the line x equals 3, wouldn't that be a vertical asymptote? And watch what I do here. Menu. Hold on, I want to be able to do it this way. Oh, escape. Let's be able to see all the graphs. So menu, analyze graph. I'm not sure if this is, I'm not even sure this is going to work. Geometry, points and lines, intersection points. Click and click. Didn't give us any. I can't find any, but I know it's at 3. It said 3. There's another way to do this. Let's try this. Let's see if I can do this. How about I change? Oh, I can't change those this way. How about we do it this way? Menu, analyze graph, intersection. And we go here, click, and we go here, click. No intersections found within the specified bounds. Wait a second. I covered 3. Let's try it again. Analyze graph, intersection. Click way over here. That's at -5. Way over here. That's at +5. No intersection found. Now, how's that possible when I know the answer is 3? Well, here's the problem, kids. 3 is a vertical asymptote. So 3 is an undefined point. You can't equal 3 because it would make my denominator equal to 0. So although I came up with 3 as my answer, my real answer is undefined. Now, I've been being sloppy in these last couple problems, and I want to apologize for that. Over here, we came up with 2 answers. But look at, one of our answers is -1/2, and one of our answers is 5. And I failed to come back and check the answers. What happens when I plug in 5 right here? Or plug a 5 in right there? I get the same problem. I get that undefined vertical asymptote that I had on the last problem. X can't equal 5. So when I come out here, the only answer here is, was it positive or -1/2? I don't remember. -1/2. So you need to make sure that you check your answers. I apologize for being sloppy. Miss Newman's kids, you can yell at me later. I apologize. We have to check your answers. Have to. So we'll do that from now on. Pause this. I'm going to tell you right now, this one's a lot like that weird one we did earlier. So pause it if you think you need help. Oh, you're back. Great. All right, so the first thing we're going to do is take care of this minus by putting it right there. The second thing we're going to do is wrap parentheses in wedding band. Right here. Look at that one. Isn't that the problem? That's the problem right there. I don't like that one. It's backwards. So we're going to flip it all around. We're going to do it right now. We're going to say, okay, you're really negative x minus 3. It's that -1. It's like a modified. It's another version of that -1 rule. If you have this, x minus 3 over 3 minus x, you can cross them out, but it makes -1, right? We talked about that a couple days ago. Okay. Or I can just flip it and make a -1 here. That's another way. So these two negatives make a positive. All right. So let's figure this out. 1 over x plus 3 plus 2 over x minus 3 equals 4 over x plus 3 x minus 3. Now, since I screwed up before, maybe we should keep track of the fact that what answers would I have to get rid of here? What answer would cause problems here? Negative 3. What answers would cause problems on this one? Positive 3. And both positive and negative 3 cause problems here. So if I end up with a 3 as an answer, I got to get rid of it. Don't know if I'm going to, but I would have to get rid of it if I end up with a 3 as an answer. All right. So let's see what's missing. This one's missing an x minus 3. This one's missing an x plus 3. And this one's not missing anything. So once I have a common denominator, I can set the numerators equal to each other. So x minus 3 plus 2x plus 6 equals 4. All right. So 3x plus 3 equals 4. 3x equals 1. Divide by x, and I get x equals 1 over 3. Now, 1/3 is not a problem. 3 would be a problem, but 1/3 is not a problem. All right. I think we got 2 more problems left. Why do we have to check for rational equations? I think I've driven that point home today. What we want to check to make sure our answers do not make the problem make any of the denominators equal to 0, because it would be undefined. Now, I am sure that you people can come up with a better way, but really that's all I want you to get at. We want to make sure that the answers that we come up with don't make any of the original fractions undefined, because they can't be solutions. What is happening on the graph? What is happening? I can't believe we're going 13 minutes. What is happening on the graph when they do that check? And this is the reason why I went to that whole graphing thing with you. What's happening is they are vertical asymptotes. I misspell asymptotes all the time. S-Y-A-Y-S-M-P-T-O-T. I would have got it right. T-O-T-S. Totes. They're vertical asymptotes. So if we have points that don't graph or don't solve or are undefined, those are when we have vertical asymptotes. All right, kids, that's the end of the day. Goodbye. Goodbye. I hope my mouth is going along with the words, so sometimes they get a little funky and it sounds really weird. Bye.